Hey folks, so let's keep going down with this idea of this p function, right? We remember p equals the negative log. So when we see p in front of something, we know we're taking the negative log of whatever that p is. So for example, we've been using these, equilibrium constants, k, like Ka, to assess the strength of a weak acid. Well, if we take pKa, then what we're doing is taking the negative log of the Ka value. And why is that useful? Well, that's useful because instead of having to like regurgitate this, like 1.76 times 10 to the negative 5, if we turn that into a pKa, then the number is much easier to deal with. And you'll see what I mean here in a moment. So let's calculate all of these pKa values. Okay, so I'll demonstrate to you how I do that with just the first one. So if I wanted to convert this 1.76 times 10 minus 5, the Ka into a pKa, I just simply take the negative log of 1.76 times 10 to the negative 5 for acetic acid. And let's do that. So on my calculator here, I'll say 1.76 E5 negative is how I have to put that in this calculator. Okay, there it is. And now I'll take the log of that. And then I remember that it's negative log, and I could do that in my head, or I could just say times 1 negative equals, and now I get, you can see 4.75 for the pKa for acetic acid. And so now, even though those numbers look totally different from each other, right? One is 1.76 times 10 minus 5. The other is 4.75. The numbers, the constant, it's the same. It's just a different representation of that number, okay? So now I've already got the rest of these calculated. You should do that yourself just to make sure that you know that you can do it. But I'm going to go ahead and put those values down. So for formic acid, that ends up becoming 3.75. And now when you look at the difference between these numbers, right, they're both about the same in the first number, 1.76 and 1.77. And now this is times 10 minus 5, and this is times 10 minus 4. And you can see the pKa has dropped by a whole unit. Okay, so we'll finish the rest of these, and we'll kind of see what this trend means. Hydrofluoric, Ka is 6.8 times 10 minus 4. The pKa becomes 3.16. The pKa for hypochlorous is 7.53, and the pKa for nitrous is 3.39. And so now, so make sure that you can get to those same values, okay? And so now, what if we wanted to interconvert back, just to make sure that we could do it the other way? So what if I had, for example, the pKa, and I wanted to go back to the Ka, okay? Well, if we know pKa equals the negative log of Ka, if I wanted to do the opposite of that, if I take 10 to the power negative pKa, that's going to give me back the Ka. So let's test that to see if that works. And let's play with the hydrofluoric as an example. So if I say 10 raised to the power negative 3.16, let's see what I get. And so the way I do this on a scientific calculator, I say 3.16 negative. And then let's see, I've got a couple of options here on what I can raise it to. So we'll say, I think I can do this button here and say 10 equals, nope, that wasn't it. Okay, so you're seeing me flub around here. So I suppose I could say, oh, you know what? I got to go 10 raised to the power 3.16 negative equals, there we go. So I just did it backwards. And so now you can see that I get 1, 2, 3, 4. So that works out to be 6.9 times 10 to the negative 4. And you can see over here it's listed as 6.8 times 10 to the negative 4. That's fine. I likely needed just some more sig figs to make those numbers work out. Okay. So now, what is that? How does that trend compare to the Ka trend? All right. Well, we remember when we were calculating, or when we were like trying to rank these things in terms of their strength. We remember, I'll put this little category right here. Let's move this over. Okay. And I'll say rank. So hopefully you remember that the hydrofluoric was the strongest out of all of these weak acids because it had the biggest Ka number, right? Well, now you can see that in fact it has the smallest pKa. Okay, so now if we keep going with that trend, we can see the next strongest acid would be the nitrous. Okay, because at 4.0 times 10 minus 4, that Ka is just a little bit smaller than the 6.8 times 10 minus 4. So that's in the number 2 position. The formic is in the number 3 position. The acetic is in the number 4 position, and the hypochlorous is in the number 5 position. So hopefully you can see this trend now. A small Ka equals a big pKa, and vice versa. Okay, and so now chemists, we're lazy people. We like using this Ka. It's just easier to say 3.16 versus saying 6.8 times 10 minus 4. Okay, and so we expect the same relationship with Kb and pKb as well. All right.